Good day, guys. Today we'll be looking at the topic sequence and series. So what do we mean by sequence? We have sequence is a set of ordered list of numbers, just as you can see. That is, when we talk about sets of ordered, that is numbers that followed patterns. So for example, talking about numbers that followed pattern, we said e.g. for example 2, 4, 6, 8, 10, and then so on. So sequence is just a set of ordered numbers that followed some pattern. So if you take a look at this set of numbers, now look at this. We have 2, that is, when we added 2 to this, it gave us what? The next number 4. When we added 2 to this, gave us the next one, which is what? 6. So we discovered that the addition of plus 2 will give us the next value, plus 2, plus 2, plus 2. So we were able to discover that sequence is a set of ordered list of numbers. Now, not just any list of numbers, that is ordered, that followed a pattern. Now we have two types of sequence. We have the arithmetic. We have more than 2 actually. We'll be looking at just 2 in this class. We have arithmetic progression, which is also known as arithmetic sequence. So we can call it progression or sequence. So you can call it what? Sequence. Arithmetic sequence. And then we also have, this is the first one, we also have geometrical sequence. So have geometrical sequence, or you call it progression. Now when we talk about arithmetic progression or sequence, that is, arithmetic progression is the kind of ordered list of numbers that is based on what we call common difference. So it is a set of ordered numbers that is based on what? Common difference. Why geometrical sequence is a set of numbers that is based on what we call common ratio. Now, what do we mean by common difference? So when we talk about common difference, let's take for example this same sample we looked at. We have 2, 4, 6, 8. Now if you look at this sequence, we will discover that there's a common difference between each of the numbers. If you look at it, 4 minus 2, we have 2. There's a difference of 2 plus 2. Take a look, a difference of what? Plus 2. Difference of what? Plus. So this is what we call what? The common difference, which is represented with what? It is represented as what? As D. So that's what we call common difference. So we represent it using what? Using letter D. Why? When we talk about common ratio. Common ratio is, for example, when we have a geometrical sequence, like for example we have 3, 9, 27, for example. Now we will discover that in this set of ordered numbers, if you look at the common difference, 9 minus 3 is 7, 27 minus 9 is, so this when we look at in terms of common difference, we will discover that this minus this is what? 6. This minus this is what? We have, that will be 18. Now we will discover that this is not following a regular pattern. The pattern is different. So we discover that this is not working with the first principle, which is the common difference principle. So definitely, so let's look at the pattern that exists between this sequence, this odd number set of numbers. So what if we have this divided by this, that is 9. That is, what if we decide to multiply each of the terms by 3? that is multiply by 3, you're going to get the next term. Multiply this by 3, you're going to get what? The next term. So if you want to get the next term of this certain number here, what do? Multiply by what? By 3, and then we have what? 81. So do we see it now? So do we see the difference between common difference and then common ratio? So we usually represent it with what? Small letter r, small letter r. All right, let's take a look at some. So let's take a look very well at the term GP and then AP. All right, so we've established the fact that sequence is a set of ordered list of numbers. That's what we term what? Sequence. So when we look at difference, we have two types of sequence. We have the what? The arithmetic, which is also known as the linear sequence, that is the arithmetic linear sequence, or the arithmetic progression. And we also have the what? We also have the geometrical progression. Now let's look at the two simultaneously. So let's look at arithmetic, and then let's look at geometrical progression. So for example, we have 2, then and at the same time sequence are always separated with a comma. As you can see, are always separated with a what? With a comma. Example of GP, that's geometrical progression, we have 3, let's say we have 9, we have 27, so we have so this continuously. That is, we call this type of arithmetic progression, we call them an infinite arithmetic progression. Why? Because if you look at these 3 dots here, it signifies that it continues, it has no ending. So an infinite progression, that is a type of progression that has no what? That has no boundary, that has no ending. While a finite is one that has what? That's an ending. So just take note that's the meaning of those 3 dots, meaning it's an infinite geometrical progression or arithmetical progression. And without the dot, it means it has an ending. It is a finite geometrical progression. So example of a finite. So we call this infinite arithmetical progression. And then in terms of, we have terms like this too, and we have terms like 2, 4, 6, 8, and then 10, then a full stop. So this signifies a finite AP. So we can have an infinite GP also, and we can also have a finite GP. So now let's take a look. Let's look at the terms used. The terms used in an AP, that is in an arithmetical progression, and in a geometrical progression. What are the terms we use? Now we have this. Now we call each of these numbers, they are all called terms. They are all called what? Terms. Call it terms. That is the list. Each of those numbers are called the terms of this arithmetical progression, where 2 is the word first term. Now the first term is each of those terms are represented in, that is in their order with the subscript, that is first term represent, meaning A subscript 1, second term in that order A subscript 2, third term A subscript 3, and so on and so forth, like that. So that's how we represent the terms of an arithmetical progression, or even a geometrical progression. So that's how we represent them. So meaning this is our first term, this is our first term, that is A1, this is our second term A2, this is our third term A3, this is our fourth term A4, continuously like that. It's because this is an infinite arithmetic, so it means we don't have a last term, it's continuous. So if we have no, for example, there is no this, we don't have the 3 dots, and there's no comma at this end, so it means this is the A4 is our last term. So we can call it, you can say this, you can simply say this is our what? Last term. Our last term. So now how do we find the other terms? For example, we have an infinite arithmetical progression. How do we look for the other terms? That is, how can we generate other terms to this arithmetical progression, which we already know that this our 2 is our first term, this is our second term, our third term, our fourth term. So since we know the pattern that there is a common difference of what? There's a common difference of +2. That is, we have a common difference of what? Of +2, which is our D, as we said previously. That our common difference is represented with what? With D. So in this case, how do we find the other terms in this arithmetical progression? So it is very simple. We already know that the addition of 2 to this will result to the next term. Addition of 2 to this will result to the next term. So we can just follow that pattern. Follow that pattern by that is addition of 2 to each of the term will result to the next term. So let's add 2 to this. So at least we have 2, 4, add another 2, 6, add another 2, which is the common difference, 8. The next one will be add another 2, that is 10, add another 2, 12. So like that. That's how we generate each of them. That is the addition of the common difference. That is in an arithmetical progression. To generate other terms, we just simply what? Add the common difference. So meaning, so generating a formula for this, if our first term is A, so by the to get out that is, if our first term is A1, this is our first term. This is our first term is A1. So for us to get our second term, it means we add our what? Common difference to our first term. We get the what? Second term. So for us to generate the third term, that is, we add the common difference to the second term. So that will be what? A1 plus common difference plus common difference. Don't forget, we said add common difference to the what? To the second term. You will discover that this is the what? Second term. So plus the common difference will give us what? The third term. So in this case, if we want to generate the fourth term, what do we do? Add the common difference to the what? To the third term. So what is our third term? We have A1 plus D plus D. So adding the common difference to it, so we have plus D. It gives us the what? The fourth term. So it is as easy as that. So to generate the formula for this, so we can easily say to find the nth term of any geometrical progression, you can simply just apply this formula that says what? A plus n minus 1 multiplied by what? Common difference. So to generate as many terms as we want, we do what? We apply this formula. So let's see. We have our first term, second term, third, fourth. Now if we want to generate the fourth term using this formula, that is, we want to generate the what? The fourth, sorry, we want to generate, we have the fourth term already, so let's generate the fifth term. So to generate the fifth term, so applying this formula, so meaning our n is equals to what? 6. So meaning our n is equals to what? Sorry, we want to generate the fifth term rather. So it means our number of terms which we are looking for is what? The fifth term, which is number 5. So what is our first term? We have to note that our first term is what? 2. And then what is our common difference? That is, we've identified the pattern, that is the arithmetic progression. The common difference between each of the term is what? It's also what? 2. So let's generate the fifth term. So applying this formula, so that is the fifth term will be equals to our first term, which is what? Our first term, which is what? A. Oh, sorry. Let's apply the formulas. Let's apply the value. Let's substitute the value straight. So our A is what? Our A is 2. So that will be 2 plus, we have, that is open bracket, our n is 5. That is the fifth term. We are looking for it. Then minus 1 multiplied by our common difference, which is what? Our common difference, which is what? 2. So from there we generate our formula, which is 2 plus 4 multiplied by what? Multiplied by 2. So from this we are able to get that our fifth term. So our fifth term is equals to what? 2 plus 4 times 2, which is what? 8. So our fifth term, which will be what? 10. Do you see that? So if you look at it, don't forget our term says this. These are our term. 2, 4, 6, 8. So we are looking for the fifth term. So the fifth term will be what? If we add 2 to this, that will be what? 10. Do you see that we are right? So anytime we are looking for the nth term of an AP, we simply use this what? Formula. Okay, now let's look at how to calculate for the nth term of a GP. That is a geometrical progression. How do we calculate for the nth term of a geometrical progression? Let's take, for example, we have our geometrical progressions. We have 3, 9, and we have 27, for example. Now if you look at it, so geometrical progression is just like, we also call it exponential progressions. We also call it exponential equation progressions. So as I said earlier on, I said geometrical progressions involve what we call what? Common ratio. That is multiplied by 3. The pattern for this is what? Multiplication by what? 3. So it's an exponential progression. It's an exponential progression. So it's not a linear progression. So it's a geometrical progression. So we call the pattern we're able to generate, that the pattern that is multiplication of 3 by each of these terms. Each of these terms is going to result in the what? In the next term. So the 3 is called common ratio, which is represented as what? As R. So our common ratio is what? Is 3. So very simple. So to calculate the nth term of an arithmetic progression, we simply apply the formula that says A R is power what? N minus 1. That is A R is power what? N minus 1. So this is the formula for generating geometrical progression, the terms of a geometrical progression. Let's say, for example, let's generate the fourth term. So let's generate for the fourth term. Let's generate for the fourth term of the GP. Let's generate the fourth term of the GP. So meaning, let's write out our parameters. So let's write out our parameters. So our first term is what? 3. Our common ratio is also what? 3. And then the number of terms which we are looking for is what? That is what? The fourth term, which is 4. So applying this formula, we have A, which is what? 3 multiply by 3, then raised to the power of what? 4 minus 1. 4 minus 1. So this will result to what? 3 multiply by 3 raised to the power of what? 3. So we have 3 multiply by what? 27. So which is resulting to what? 81. So meaning our fourth term is equals to what? 81. Is equals to what? 81. So meaning this is our first term, which is always what? A1. So second term, we can also call it T2. We call it T2. That's second term. T3, third term. So T4. We're able to get our T4 to be equal to what? 81. So anytime you are asked to look for the nth term of a GP, we apply what? This formula. So that's nth term of a GP. So for the nth term, we apply the formula for what? Finding the nth term of a GP. Okay guys, let's look at how to calculate sum of nth term of arithmetical progression and geometrical progression. So first thing, we start with arithmetical progression. So let's look at arithmetical progression. So how do we calculate the sum of nth term of an arithmetical progression? So I told you, for depend on the progression, we have two types. We have for example, like arithmetical progressions. Now we have the finite and we also have the infinite. Now this, I told you, as we said earlier on, I said finite AP means it has a last term. For example, like 2, 4, 6, and then having 8. Having a 8. So having 8, we said this is a finite AP. So we call this a finite what? A finite or finite AP, and then we call this, for example, we have 2, 4, 6, and then we have 3 dots immediately after it. We call it infinite. Infinite what? Infinite AP. So we call it infinite AP. So now, taking for example a finite AP, for example, how do we calculate the sum of nth term? So calculating the sum of nth term, what do we simply do? So calculate the form. We already know this is our what? This is our first term, right? This is our second term, this is our third term, and this is our what? Fourth term. So how do we calculate our sum of m? So it's very simple. So we represent our sum of nth term of an AP as what? Sn, that is sum of nth term, equals to what? N over 2. So giving a last term. So these are what? Our last term. So when we are giving a last term, we represent it to what? Is letter L. So giving a last term, our sum of n term is A plus L, as N over 2, A plus what? L. This is sum of n term of an arithmetical progression. And then looking at a geometrical progression. Now, based on for a GP, we have two kinds. Depending on the value of our common ratio. So firstly, if we have a GP, like the previous example we've looked at, 3, 9, 27, and then let's say 81. So looking, then let's say we have an infinite term. So looking for the sum of an nth term, the sum of nth term of a GP, that is, so we have A into brackets Rn minus 1 over R minus 1. So in this case, we only apply this when our R is what? Less than 1. We only apply this when our R is less than 1. And then secondly, we have the second that says sum of nth term is equals to A into bracket 1 minus R raised to power n divided by what? 1 minus R. So this is when, this is when R is greater than 1, and then this is when R is less than 1. So that the essence is that if you look at determining the range of this equation, so the only situation where this formula is valid is when r is not equal to what? Only when r is not equal to what? Is not equal to 1. Because if our r is equal to 1, the whole equation becomes what? 0. So this equation is only valid when what? When r is not equals to what? 1. That is the condition for each of these formulas. So when r is not equals to what? 1. R is not equals to 1. So the equation is only valid when the r is not equals to what? Is not equals to 1. So this is the formula for generating the sum of nth term of a GP. We have this condition and we also have this condition. Now, before we move on, we also have formula for generating the nth term of an AP, which that is when it is an infinite progression. We have sum of nth term is equals to n over 2 open brackets 2a plus n minus 1 multiplied by d. So this when we have an infinite term. This is when we have a finite term. This is when we have a finite term. So it's as easy as this. So again, next we are going to be looking at different examples. We also have one more formula for GP, that is sum to infinity. We call it sum to what? Infinity. So when you have it up to infinity, so sum of infinity, so we call it, so that is when our n tends to infinity. How do we calculate the sum of nth term for a GP? So let's have it here. So sum of nth term for a GP, that is to infinity. So that will be sum of nth term to infinity. So that will be a over r minus 1. That the same condition applied. This is when our r is greater than what? 1. And we also have when r is what? Less than 1, which is you apply the same formula, that is, so we have this. So when r is less than 1, we have this. A over 1 minus r. So this is when our r is less than what? 1. Note, for these equations, for this formula to be valid, our r must not be equals to what? Must not be equals to 1. So we'll look at some examples on arithmetical progression and geometrical progressions. So we'll look at different examples on that. Okay, now let's look at the first question. So for the first question, we have, it says find the 4 terms of the sequence whose general term is given so. Now if you remember, I told us that a sequence is a set of ordered numbers, that is list of numbers, that is they follow a pattern, so which we call it a general term. So there's a general term guiding them. So for example, in this question we asked to determine the what, we should list the terms. So which is guided by this what? Certain general term. They've given us for general term already. So for the first question, so we have our general term to be 3 plus 7n. So we are asked to generate the first 4 terms. So meaning, we said first term, so the first 4 terms. So for the first term, which is our a, is equals to what? 1, right? That is, sorry, we said for the first term, that's us generate the first term to look for the first 4 term, that is, which are the first 4 terms, which are C1, that is first term, second term, third term, and then what? And the fourth term. Don't forget we said our first term. I said our first term is what? A. That's our what? Our first term. Then our second term is what? A. That is add the common difference to it, since we are dealing with a GP. And then the third term is add the common difference all over again, that is 2D. And then for the fourth one, add what? That is your first term plus your what? Plus 3. This is our fourth term. But in this case, we are told to look for the first term, second term, third term, and what? And fourth term. So meaning for the first term, it means our n is equals to what? 1. So let's generate. So anywhere we see n, put what? Put 1. As anywhere we find n here, we put what? 1. So we have 3 plus 7 to bracket 1. That is for our what? Our first term. So our first term will resolve to what? 3 plus 7, which is what? Which is 10. Our first term is what? 10. Then for the second term means, so to get the second term, so it means our number of term is what? That is number 2. So that is MFC, and we put what? We substitute for 2. So that will be 3 plus 7 to bracket 2. So we have 3 plus 14, which is what? 17. That's our what? Second term. Then for the fourth term, so for this fourth term, that will be what? Sorry, we've jumped for the third term. That's still 3. So for the third term, that is, we are looking for the third term. Our n is equals to what? Number 3. That's the third term. So that will be T3 is equals to, according to the general formula, to give us 3 plus 7 to bracket what? 3. So having this, we have 3 plus, that is what? 21, which gives us what? 20. For that is our third term. And then to generate the fourth term, which is T4, our number of terms is what? Number 4. So applying the same formula, we have 3 plus 7 to bracket what? 4. We have what? 3 plus 20 what? 8. So we have what? 30. So we have 30 what? 31. So now let's see. So let's list out the terms. So our first term will be what? So we have our T1 is going to be what? This is our first term. So we have it here. Our first term is going to be 10. Second term, which is what? 17. Third term, which is what? 20. 24. And then the last term, we have what? 31. So if we discover, we see that this is a GP. I'm sorry, this is an AP. That is addition of what? The addition of 7. Common difference of what? 7. If you look at it, addition of 7. Addition of 7. Addition of 7. So this is what? This is AP. This is what? AP. This is an arithmetic what? Progression. So now let's look at the second question. That is the part B. Now for the part B says, so we are guided by this rule that says what? So we have 7 multiply. So we have 7. Sorry, let's clean this off. So we have 7 multiplied by 3 is power of what? N. So we are told to, this is general term. So we are told to generate the sequence of that is generate the first 4 terms of the sequence. So how do we go about it? So for the first term, for our first term, we already know our n is what? 1. So that will be 7 multiplied by 3 raised power 1, which is what? 21. For our second term, we have our n is equals to what? 2, which is what? That will be, so T2 is equals to what? 7 multiplied by 3 raised power what 2, which is what 7 multiplied by 9, which will solve to what, that is 50 what 56. That is what 63. So next we move on to the third term. So to the third term, so that applying the same formula, our n is equals to what? Our n equals to what? 3. So that will be 3. 7 times this, 3 raised power 3. So we have 7 multiplied by what? 27. So our third term is what? 7, which is what? 189. So that's our third term. So now let's derive the fourth term, which is the last one. So for the last term, which is the fourth term, so that will be T4 is equals to, applying the same formula, 7 multiplied by 3. Now in this case, our n is equals to what? Because it's the fourth term, so our n equals to what? 4. So applying the same formula, so we have T4 is equals to, this is raised power what? 4. So 7 times 3, so 3 raised power 4, we have 81. So we have 81 multiplied by 7, which we have what? 5, 6, 7. So that's our fourth term. So if we list out the terms, we are going to be having our first term to be what? 21. Second term to be what? 63. The next one to be what? 189, and the last one to be what? 5, 6, 7. So we see that this is a what? This is a GP. This is a what? A GP. How do we know that it's a GP? So look, we see that they have a common ratio of what? A common ratio of, there's a common ratio of what? Common ratio of 3. So if you multiply this by 3, you have the next one. By 3, you have the next one. And by 3, you have the next one. So that's an example of what? This is a GP. Alright, so now let's look at, we'll be looking at another question. Next question. Alright, the second question says, find the 40th term of the linear sequence. We have 6, 11, 16, and then 21. So we are told to look for the what? To find the 40th term of the linear sequence. So in this case now, what do? We can't start listing each of the term by one. No. So we already have, what's the formula for finding the nth term of the AP? First thing, let's determine. So I told you linear sequence also means what? It also means AP, arithmetic progression. So let's determine all our parameters from the sequence. We have 6, 11, 16, and then what? 21. So from this, we have that our first term, which is what? A, is what? 6. Since we have been told that it is a what? It is a linear sequence. So since the linear sequence, there should exist what we call what? Common difference, which is D. So meaning second term minus what? Minus the first term. So what's our second? This is our second term. I thought this is our second term. This is our third term, and this is our what? Fourth term. So common difference means T, that second term minus first term, third term minus second term, or what? That is, I can do T2 minus T1, or I can decide to do T3 minus T2. So that will be what? 11 minus what? 6. So our common difference D is what? 5. Now we know our common difference, and then our first term A is what? A is equals to 6. So we have our first term, we have our common difference, and then the formula says for nth term of an AP, for the nth term of an AP, we have our formula says A plus N minus 1 multiplied by what? D. That's what our formula says. So applying this formula, we already know our, so now we said what term? It said find the 40th term. So meaning, since it is the 40th term, our n, that is number of 10, is what? 40. Is what? 40. So we are looking for the 40th term. So substituting into this formula, we have A, which is what? 6 plus our n, which is what? 40 minus 1 multiply by our d, which is what? 5. So now we have what? 6 plus 39 multiply by what? By 5. So now we have our Tn to be what? That is 6. Now this multiplied by this gives us what? 195. Sorry, give us 195. So adding our 6 plus our 195, we have the sum of what? 200 and what? And 1. So that's our what? T. That is T40. That's our T40. Sorry, no longer Tn. So it should be T40. So it should be T40. So the 40th term is what? 201. As simple as that. So next question, let's look at the next question. So our next question says the fourth term of an arithmetical progression is 15 and the ninth term is 35. Find the 15th term. Now, how do we approach questions like this? Don't forget, we are still working on arithmetic progression. So first thing is to interpret the question accurately mathematically. Now the question says from the first sentence, this fourth term of an arithmetical progression is what? 15. So representation for fourth term is what? So our fourth term is equals to what? 15. And the second, they said, and the ninth term is 35. That is, ninth term is what? 35. Then the question says find the 15th term. Find the 15th. Find the 15th term. Question mark. So how do we approach this question? So we have two statements. It says the fourth term is 15 and then the ninth term is what? 35. So the first thing, we already know to calculate the nth term of any AP. The formula says we have Tn is equals to A plus N minus 1 multiplied by what? By D. That's what the formula says. So first thing, we have to before we can get our nth term, we have to determine the what? The first term and the what? Common difference. We already know our n is what? 15 because they asked to look for the 15th term. So how do we determine our first term and our what? Common difference? So very easy. So what we just have to do is what? Is to follow the statement which we are being given. So we have been told that our fourth term is what? Is 15 and our what? Ninth term is what? 35. So let's take the statement one after the other. So we have that our fourth term is equals to, that is A, substituting it, don't forget. So we are looking at our fourth term, calculating for the fourth term. We already have the fourth term is equals to what? 15. Our n will be what? N, that since we are dealing with the fourth term, so n is what? 4. So the formula for fourth term will be what? So the fourth term is equals to A plus n, which is what, 4 minus 1 multiplied by what, D. So don't forget our fourth term is of 15, so we have 15 is equals to A plus 3D. Sorry, 3D. So these are what, fourth term. So we call this, we label this as what, equation 1. So we got this equation from the first statement rather. So now let's move to the second statement, which says our T9 is equals to what, 35, and then our what, n will be equals to what, because we are dealing with the ninth term, our n is what, 9, which is the ninth term. So applying the same formula, so we have T9 is equals to A plus what, 9 minus 1 multiplied by what, D. So we have T9, which is what, 35. Sorry. A plus 8 times what, D. So that is what, so we have A plus 8D is equals to what, 35. So we can call this our what, equation what, 2. So now we are able to generate two equations from this what, single questions, from these two statements. So next thing is solving them what, simultaneously. So we could see that solving them simultaneously, we can get our what, our A and our what, and our D common difference. So how do we solve them simultaneously? So with our idea of simultaneous equation. So let's go. So we already have our equation 1 is A plus 3D is equals to what, 15. And our equation 2 is A plus 8D is equals to what, 35. Alright, so we can clean all this off. So now solving this simultaneously, this is our equation 1, and then these are what, equation 2. So solving this simultaneously, so since we have the coefficient of A to be equal, so what we just simply do is what we subtract. So subtract equation 2 from equation 1. So this we cancel out, and then we have minus 5D, which is equals to minus 20. Then from here we have minus cancel minus, and then we finally have our D is equals to what, 20 divided by what, 5, and then our D is equals to what, 4. So that's our common difference. So the next thing is substitute for D in equation, any of the equations. So let's use equation 1. So substituting for D, we already have that our D is equals to what? Our D is equals to, that is 4. So substituting for D, so we have from equation 1 we have A plus 3D equals to what? Equals to 15. So substituting for D, anywhere we see D, we put what? 4. So we have A plus 3 multiplied by our D, which is what? 4, equals to what? 15. So applying that, we have A is equals to 15 minus 3 times 4, which is what? 12. So we have our first term, which is equals to what? 3. So now we have our first term and our what? And our common difference. So we can easily find our what? The what? 15th term. So let's calculate for our 15th term. So the formula says for 15th term is what? A plus 15 minus 1 times D. So what is our A? So we already have our A is what? 3 plus, that is 14, common difference, which is what? 4. So we finally have 3 plus 14 times 4, which is what? 56. And then our final answer, which is our T15, is equals to what? 59. So that is our what? Our 15th thing. Given that, said question first is find the value of x. Given that x plus 1, comma 2x and then 2x plus 3 are consecutive terms of a linear sequence. So we are told by these are consecutive terms of a linear sequence, which is what? An AP. So let's list out what we've been given. So we are told that x plus 1, 2x and then 2x plus 3 are what? Are the terms of its consecutive. So meaning we can decide to say, then we can say these are what? These are first term, and then these are what? Second term, and these are what? Third term. So we already know our first term according to this given equation. Our first term is equals to what? X plus 1, and then our second term, which is A plus D, is equals to what? 2x, and then our third term, which is what? A plus 2D, is equals to what? 2x plus 3. So we have been told that these are consecutive terms of a linear sequence. So now we already know that the nth term of an AP, the T-nth of an AP, is calculated using this formula. But in this case, we are not asked to look for what? Any nth term, but instead we are asked to look for the value of what? The value of x. So what can we apply? What rule can we apply for us to determine what? Our value of x. Now note, we already know that our common difference, which is our D, is equals to what? So our common difference is the difference between the second term and the first term, third term and the what? Fourth term, fifth term, and like that and like that. That is, our common difference is the difference between T2 and what? T1, which is also the same thing as T3 minus what? T2 in this case. So meaning the difference between our deep common difference is also the same thing as what? Okay, so we can say difference between the first, the second and the third and the first will be what? That is 2x minus the second term which is given, and the first term which is given x plus 1. Don't forget, this is our what? These are our first term, and these are what? Second term. So let me use same, that is, these are our first term and that's our second term, and according to the formula it says T2 minus what? Sorry, this is our second term, and these are what? First term. So second term minus T1, that is the formula. This is the formula we followed. So now to continue, so that is for the first one, and then for this other statement also, our common difference is also what? T3 minus what? T2. Where's our T3? T3 is 2x plus 3 minus 2x. That is, these are what? T3, and these are what? T2. So comparing the common difference, since we said common difference is that this is same all over the terms, so meaning the common difference are both what? Equal, they are equivalent to each other. So meaning we can just simply write, so we can say so simplifying this first equation here, we're going to have let's call it D1, and then let's call this D2, but don't forget they are always what? Equal to each other. So let's see, so our D1 will be equals to 2x minus x minus 1, which will resolve to what? X minus 1. That is our D1. Now let's solve for D2. So D2 will be equals to what? 2x plus 3 minus 2x. So we have 2x, we cancel 2x, which we have what? 3. So that we have our D2 equals to what? 3. Now comparing the two we said the D remains constant all through. So D1 is also the same thing as what? D2. We are going to have this. So our D1 is what? X minus 1. And we said there it is equals to what? D2, which is what? 3. So we have a simple linear equation. So we can find the value of our what? X. So then we can say x is equals to what? 3 plus 1. So our x is equals to what? 4. So the value of x which you are told to look for is what? 4. So now let's generate the terms. Don't forget, let's generate the term. We have x plus 1, 2x, 2x. So our first term will be what? Like that. Since our x is equals to what? Our x is equals to 4 already. So our first term will be what? That's 4 plus 1, which is what? 5. Second term will be 4 times 2, which is what? 8. And our last term will be 4 times 2, 8 plus 1 plus 3, that is what? 11. So these are what? These are 10. So if we look at it, this is what? It is an AP. So if you add 3 to this, give us next term, and if you add 3 to this also, to give us the next term, which makes that what? An AP, arithmetic progression. All right. So now, question 5 says the second term of an exponential sequence is 35 and the fourth term is 875. Find A, the first term, and B, the fifth term. Now, if you look in this case, now we are doing, you said of an exponential sequence. So I told us an exponential sequence is also the same thing as what? A geometrical what? Sequence. So now we are dealing with what? With the GP. Now we are dealing with what? GP. So how do we work with GP? So let's go. So first thing, let's interpret the question. So the question says the second term, which is what? T2 with GP is what? 35. And then the second statement says the fourth term, which is what? T4 of GP is also what? 875. Then it says find the first term and the fifth term. So just like in terms of our AP, before we can get the nth term of an AP or a GP, we have to first know the pattern, that is, know the first term and the common ratio, that is in this case of exponential sequence. So we need to know the value of our first term and our common ratio. So how do we get our first term and our common ratio? So the first thing is to determine our first term and our common ratio from the given data. So we have been told that the second term, which is T2, is 35. So how do we go about that? So interpreting that, what's the formula for calculating the nth term of a GP? So we have the formula for calculating the nth term. The nth term of a GP, which is A R n minus 1 raised by n minus 1. So how do we calculate that? So substituting the given data. So for second term, we don't know the value, but we do know that our number of terms will be 2, because we are dealing with second term. So substituting inside the formula, we have second term. Okay, they told us that our second term is 35. Our second term is equals to 35. So our second term is 35. So calculating for the second term, so we are going to have A raised power n, rather, that is R, AR, then n, which is 2 minus 1. So we are going to have 35 is equals to AR raised power 1. So having this, so we can term this, that is, let's rewrite the equation, that is AR is equals to 35. So let's call it equation 1, that is from the first. So let's call this equation 1. Now let's proceed to the second statement, which says our fourth term is equals to 875. So interpreting this, so that is, we have our n is equals to 4, and then our T4 is equals to 8. So putting inside the formula, so we have T4 equals to A is for R, our n is 4 minus 1. So our T4, which is 875, is equals to A R raised by 3. So we can simply call this equation 2. So just like just like in our AP where we have some 2 equations, so in this case too we have 2 equations, so we just need to solve them simultaneously. So we have, for the first one, we have AR is equals to we have 35, and then for the second case we have AR raised by 3 is equals to we have 875. So solve them simultaneously. So let's divide. This is equation 1, and then this is equation 2. So divide equation 2 by equation 1. So divide equation 2 by equation 1. So how do we go about that? So equation 2 says AR raised by 3 is equals to 875. So dividing it by equation 1, so we have divided by A raised by 1, then divided by 35. Now in this case we have A would cancel A would cancel A, and then according to indices we have R is by 3 minus 1 equals to, so 875 divided by 35 will give us 25. So we are left with, we have R raised by 2 is equals to 25. So then to get the value of our r, we can just simply do what? Root both sides, square root both sides. So we have r is equals to what? 5. So our common ratio is equals to what? 5. Now let's determine. So we already know our common ratio. So our first term will be what? So substituting for r in, let's say, equation 1. So from equation 1 we have, so from equation 1 we have, well, we have a r equals to what? 35. So substituting for r, we have a times our r is what? 5, which is equals to what? 35. Dividing both sides by what? 5. We have 35 divided by 5, and then our a will be what? 7. So we have it clearly that our first term is equals to 7, and our common ratio is equals to what? 5. Now the question now says what? Find the fifth term. So now we know our first term and our common ratio, so we can now find the what? Fifth term easily. So fifth term says, the formula says a r raised to power n minus 1. So our n is already 5 because we are dealing with the fifth term. So we have 7 multiplied by our r, which is 5, raised to power 5 minus 1. So we have 7 multiplied by, so this is 5 raised to power of what? 4. So we have 5 raised to power 4. So we have 7 multiplied by 3, 1, 2, 5. So multiplying it by 7, so we have 21,875. So that is our fifth term. So our fifth term is equal to what? 21,875. So now we have So we have 7 multiplied by, so 5 raised to power 4, which is what? 6 to 5. Then 7 multiplied by 6 to 5. So we have our fifth term, which is what? 4, 3, 7, 5. So the sixth term of our what? Of our GP is what? 4375. Okay, question 6 is find the two possible values of p if p minus 3, 3p plus 5 and 8p minus 5 are the three consecutive terms of the geometrical progression. So you have been told that the three terms of the geometrical progressions are, you have p minus 3, 3p plus 5, and then we have 18p minus 5. So they say there are three concepts. So meaning this is our what? First term. This is our first term. This is our what? Second term, and this is our what? Third term. So according to GP, we know that our common ratio is it what? The division of the what? Second term over what? First term, which is also the same as what? Third term divided by what? First term. That's how we determine our common ratio. So in that case, to determine our common ratio in this case, so our common ratio will be equals to T2, which is 3p plus 5 divided by T1, which is this over this, which is also equals to T3, which is also 18p minus 5 divided by what? T1, which is what? T2 rather, which is 3p plus 5. Now solving this equation, we have 3p plus 5 divided by p minus 3 equals to, okay, let's just move straight. So we have cross multiply, So we have 3p plus 5 is multiplying 3p plus 5 equals to 18p minus 5 is multiplying what? P minus 3. So now we have expanding, we have 9p square, that is this, we multiply this we multiply this, and then this we multiply this we also multiply this. So expanding, we have 9p plus 15p plus 15p plus 25. So let's say this is our what? This is our left hand side, and then this is our right hand side. So simplifying the left hand side, we have 9p square plus 30p plus 25. So these are our left hand side. These are our left hand side. So simplifying the right hand side, expanding the right hand side, that is same thing, performing the same rule we did here. Performing the same rule we did here on this. So we're going to be having, that is, this is multiplying this is multiplying this, and same thing like that. So we have 18p square minus 5p. Okay, let's do it accordingly. 18p square, and then we have and then secondly we have this time, this is minus 54p minus 5p, and then plus 15. Simplifying that, we have 18p square minus 59p plus 15. So this is our what? Right hand side. So bringing the two together, we have 18p square 54p, sorry, 18 for the left hand side, we have 9p square plus 30p plus 25 is equals to 18p square minus 59p plus 15. So simplifying this, just like collecting like terms, do we get it now? So it's just like collecting like terms. So we are going to be having, let's bring this to the other side. So we are left it. So I'm moving everything to the right. That is everything on the left hand side to the right hand side. So we are going to be having everything left to be 0. So we're having 18p square, we are arranging minus 9p square then minus 59p minus 30p plus 15 minus 25. So what we did is that we moved everything here to the what? Right hand side. So moving everything here to the right hand side, every term with positive will become negative, every term with negative will become positive. So that is just the idea. So now let's continue simplifying. So simplifying this and this will give us what? 9p square then simplifying this and this, minus 59 minus 30, that is minus 89 p, then minus 10 equals to what? 0. Equals to what? 0. So solving this this is a quadratic equation, that is the highest power there is what? 2. So solving this quadratically, you see our highest power is what? 2. So it means the quadratic equation. So solving it quadratically, we have this multiplied by this. So solving it quadratically, so we are going to have 9p squared minus 18, that is minus 10p minus 10 is it 9p, so that will be 10p, that will be 10 times 9. So we'll just, in simple term, what we'll do is, let me just quickly explain that. So what we'll do is this multiplied by this, so to give us what? Minus 90 p square. You can decide to use formula method also, so I'm using the factorization method in this case. So depending on how the case may be, you can decide to use any method, So we have t multiplied by what? 1, that is pp. So our value will be 9p square minus 90p plus 1p minus 10 equals 0. So we have, in that case, we have 9p into bracket, factorizing 9p out. So you have p minus 10 minus 10, factorizing 1 out in the second expression. Then we also have p minus 10 equals 0. So factorizing the quadratic equation, we have 9p minus 1, and we also have p minus 10, which is just 0. So our final solution, we have p will be equals to 1 over 9, and then we also have p is equals to what? 10. So these are the two solutions of our what? Of our p. That is, p is equals to 1 over 9, and then p is also equals to what? 10. So that's what the question says. The question says what? Determine the value of what? Of p, the two values. So these are the two possible values of what? Of p.